My talk is based on some of the experience I've had in the past few years about how DevOps has changed the way I think about software development. And so what I've realized is that embracing DevOps can be a huge benefit, but it can also be very difficult to get it right. So this is sort of a preview about what you can expect for your investment in adopting DevOps practices, and maybe some advice on what you should pursue and what you should try to avoid. It's not working. All right, so I'm from the Des Moines area. I've been applying and learning Agile practices since about 2005. And one of my first experiences with Agile software development was in the database space. And so I'm kind of bummed I'm missing out on Pramod's talk upstairs on Agile database and DevOps database practices. But I'm glad to hear that recorded, so I'll see that later. I've been immersed in a DevOps team for about 3 years. And so this is kind of based on my experience in that space. This is the abstract. You've probably already read this. This is on the speaker website. So I'll summarize some of this. DevOps practices help increase your flexibility, your quality, and reliability. But it can be a really complex maintenance burden, and it's really difficult to get it right. So I'm hoping that this talk can help you learn how to learn from the mistakes of others, and also identify what some of the successes are and what you should invest in. So what do I mean by a game changer? A game changer is something I see as something that moves the needle by an order of magnitude. And this is going to be what sort of drives business to really want to make an investment in order to get some sort of benefit. And if you do it right, it's going to feel like you're cheating. So being able to deliver 10 times faster, do it at 1/10 of the cost, those are all examples of what I mean by a game changer. But if you don't do it right, then you could find yourself on a crash course where you've just got way too much complexity. It takes 10 times longer. It costs 10 times much. So this is the situation where DevOps can go wrong, and you have essentially disaster ops. So the 3 main points essentially are what is DevOps and what isn't DevOps, how to avoid disaster, and some effective DevOps practices. So we'll start with what is and what isn't DevOps. So what do I mean? What do I mean by the word DevOps anyway? So let's let computers do the work that needs to be repeated with precision. DevOps is not an achievement. There's no box you can check to say DevOps now, or just like there's not with Agile or Agile now, right? And your customers don't care if you're using DevOps or not. There's no award for a successful implementation of DevOps. But maybe you get to spend more time with your family instead of supporting production. And maybe you get to speak at cool conferences like this one. DevOps is not some separate team that does all your infrastructure and deployments. If you've got one guy in your team that does all the DevOps stuff, that doesn't count. That's not DevOps either. Now, automated ops, that's okay, and if that's working for you, you can stop there. But that doesn't really count. That doesn't qualify as DevOps. DevOps is not the cloud, but often it's associated with it or synonymous because cloud platforms provide good ways to script out, and they encourage good practices so that you can leverage them to get an automated infrastructure. Does anybody remember Game Genies? Yeah. So I feel like DevOps is like you just bought a Game Genie, and you've got all this new power, right? And you have all these new options. And frankly, it makes video games kind of boring because you can just beat them all. But I mean, that's awesome when that's the power you get from your business. So DevOps is more of a culture where the teams take responsibility for the operational support. And in order to do that, they need to master technology to get insight, feedback, reliability, and monitoring. So DevOps is going to change the way you approach problems because there's going to be new options available, making operations a first-class concern with better logging, retry logic, visibility, reliability, and systems that can heal themselves is going to be something that makes a big difference in how you approach even developing new features. The way you get feedback and see how your customers use your software is also going to be something that is impacted when you have the option, when you have that power of DevOps. So DevOps is a strategic business decision to create a value stream for delivering more frequent and reliable software. And it helps you shorten your feedback cycles and evolve your software delivery pipeline. Or really, DevOps isn't really as sexy as it sounds. It really just means that you get to support your own code in production at 3 a.m. And so this drives some interesting incentives, because if you're the one that's going to be responsible for answering that phone call, you might have a little bit of reluctance on releasing something that you know you're not proud of, something that's low quality, something that doesn't have good error handling, something that is going to wake you up and make you deal with it. And so if you want something done right, you do it yourself. So make the team that's writing the applications responsible for supporting them, and you're going to get higher quality. So that drives the right incentives. So in DevOps, our servers are not pets. Has anybody ever requisitioned a server before? All right, how long did that take? Did you get it within 6 months? Yeah, we want them within 6 minutes, and we want them exactly with what we ordered on them. And unfortunately, we don't get to name them. They'll probably have some generated name, but that's okay. We're going to treat servers like cattle. Servers are ephemeral, which means that they are replaceable. They'll come up and go as they're needed. They're designed to be slaughtered from the moment you bring them up. And once they've fulfilled their purpose, you're done with them. You don't care. So if a production server is acting weird, it's a perfectly reasonable thing to do to kill it, and then let a new one, a healthy server, come up and take its place. And this too can be automated, so you don't have to deal with it. DevOps also makes security patches a little bit easier, a lot easier, because you can lay down your system requirements and infrastructure on top of a OS that's already been patched and is up to date. So that makes it more seamless. With DevOps, we can create systems that are self-healing. And this allows us to have a lot more resilience and reliability. So when I've been on call before for a system that we had DevOps engineering behind, when something goes wrong, I'll get an alert. I'll have to log in, go check it out. You have to sign into the VPN, go find the logs. And by the time I do that, which maybe takes 10 to 15 minutes, I recognize that the system's already responded to what the issue was, it's already healed itself, and notified me that it's back in a healthy state. So to me, that's a big win. With DevOps practices, we can also create systems that automatically scale up and down to handle and respond to the load. And we can also scale appropriately for running at an economic advantage and have lower cost. DevOps also is kind of interesting because it sort of changes the physics of the software world. what used to be an architecture decision, which is stuff that's hard to change after you've made a decision on it, sometimes those decisions can become runtime decisions. And that is, again, one of those things that gives you more power and allows you to have more options. So in one situation, we had a server that had been chewing on some incoming file for a couple hours, and all of a sudden the server went unhealthy, was taken offline, replaced by a new server. That file bounced back into the queue, was picked up by another server, and all of a sudden this was like a poison message that was just killing servers. And we figured out what was going on was that it was blowing out the memory on the computer. So we made an infrastructure change, deployed that to production. I think we got a machine, we just went overkill, 4 times the RAM. And we had that deployed into production in about 10 minutes. The next server that picked up that file processed through it, and it was just a giant file, something we'd never seen before. And then everything was healthy, everything was fine. And then we were going to tune it back down, and then we looked at the cost comparison, and we recognized that it was about a 1 cent savings per CPU hour, and so we just left it at a higher RAM. We traded CPU for RAM, but in that case, CPU wasn't the bottleneck anyway. So, but being able to make that change, recognize it, and get it deployed and processed within 10 minutes, like that, it wouldn't have been possible. If you couldn't process this file before because you needed to add RAM, the customer would have just been waiting on that file for probably days or weeks. DevOps also introduced some interesting incentives and dynamics to how your work flows through your team. So you have to balance these priorities of infrastructure concerns and feature delivery along with side by side together, so that it might feel like you're going slower, but what you're really doing is you're investing in your delivery pipeline. And I don't know if any of you feel overwhelmed by the technology choice, but we've just had an explosion of technology recently. These are the kind of those waves of innovation crashing that Andrew talked about. And so this is more of a caution to be selective in which tools you pick for your delivery pipeline, because you might just end up supporting that in the middle of the night. And a lot more choice is also a complexity amplifier. And a lot more technologies introduce a lot more learning curves. And so it's not that the curve is steeper, it's just there's so many of them. And just because the technology is new, it doesn't mean it's good. So it's up to you to do the investigation to see what's this niche this technology is aiming to fulfill, and does that fit what our particular need is for our situation and for our business. You're going to have to just expect to have a learning curve and to invest in training. And just because your cloud provider offers this service as a managed service, you don't have to use it. You can pick a couple of things that work for your existing architecture and get good at those before you try to use a large variety of technologies or services that are available. Your first move to a cloud platform should be something like just a lift and shift, and then try to automate some of those infrastructure pieces. I would strongly urge you not to try to refactor your existing application to microservices, because microservices equals massive orchestration. And until you get really good at deploying a monolith, microservices is going to add a lot more complexity to it. So in short, DevOps is awesome. It kind of is an extension of that Agile manifesto of individuals and interactions over processes and tools. So has anybody ever experienced Scrum dread before? Like, okay, Scrum's great, but these ceremonies and stuff are getting kind of old and maybe a little boring. So has anybody ever been to a release party where you deploy your apps to production? Yeah, that shouldn't be a thing. Deploying to production should just be a boring thing that happens a few times a day. And this is just an extension, like a natural extension of Agile principles. So release parties were back, they were fun back in the early 2000s maybe. But. So let's move on to how to avoid DevOps disasters. Has anybody ever deployed their first deployment to the cloud? Did it go well? Yeah, well, what works on my VM, right? Have you heard that phrase? That's the new phrase. So you should just expect things to go wrong, but you're going to take your first deployment and see, okay, what can we learn from this? And how do we need to change what our pipeline looks like? How do we need to change what our infrastructure scripts look like? And getting familiar with all the other things such as like firewalls, your security stuff, like maybe those are areas that we're not experts at yet. And so we're going to need a lot of help from other areas. Never lose the ability to run your build locally. If you can unplug your Ethernet cable, shut off your Wi-Fi, and run all of your tests, then you're in good shape. If you have to be connected to other services or use your cloud provider, you can only run the build in the cloud, you've messed something up and you need to fix it. Fix broken Windows. I know this isn't Microsoft Windows. That can be broken, that's fine. But technical debt is more of a problem, and you have to fix dealing with stuff that you don't let it get to a state where people don't care anymore. And this is the lessons back from the pragmatic programmer. And this also applies to your infrastructure pipeline as well as your code base. You want to keep your code and your pipeline nice. You want to be proud of it. If you're trying to introduce some kind of a workaround because of some existing technical debt, it might seem attractive to do that, but it's probably a trap because in the long run, it's going to cost you more in maintenance and support than it would be to just fix the root cause of the problem. So a sign of this may be a custom build plugin or forking an open source project rather than just making the contribution back to the open source project. If you bypass your automated deployment pipeline to fix this one thing for today, or if you're going to do something manually that you have automation for, that you recognize you need to automate, those are all signs of taking shortcuts that are going to end up burning you in the long run. So anybody ever heard this phrase before? There's more than one way to... Yeah, we're not going to skin a cat. We're going to skin a cat, right? A catfish. This is where this phrase originates from. And so some ways are better than others. And just because you thought of a way to do it doesn't mean this is an easy way or the right way or something that you should be supporting. So oftentimes, there's already a technical solution in place. There's already a tool in place. You don't have to invent something. You don't have to write something that's specific for your situation. And oftentimes, the first time you try something, it's just going to be a bloody mess no matter what. So just try to learn from that first time, and then try to go back and invest in how do we make this simpler? How do you make this something you can support? So Fred Brooks wrote this article called No Silver Bullet. And he draws an interesting contrast between accidental complexity and inherent complexity. And the stuff that we're doing is inherently complex. But it's up to us as technologists to reduce the accidental complexity so that we don't exacerbate the time it takes for maintenance, support, and try to just get understanding about what's going on in the solutions we create. So if somebody calls your code academic, exceptional, or clever, it's not a compliment. You need to go back and fix that and make it simpler so that we want to employ the principle of least surprise. So when somebody goes back and looks at your code or a build pipeline, they see the script and they say, oh, well, that was obvious. Why did I bother looking here? It does exactly what it said it was supposed to do. Another caution is do not overcrowd your accounts. You will run into limits, throttling. You might even run out of IPs in your subnet. And it's just going to be a blocker. It's going to cause you a heartache. Also, never eat exceptions. Nothing will drive you batty like trying to figure out a problem only to realize somebody skipped the catch block and the exception's not being logged, and so you have no insight to what's happening. And then the server's gone, so you have no way to go back and see what's happening other than run through a debugger and try to reproduce the problem. All right, so let's move on to what can you do for some effective DevOps practices. So number one, you want to be able to have some insight and visibility. So we want to create some dashboards for your applications. There's 2 good talks later at this conference. Avery Regier's talk on recognizing zombies, black holes, tribbles before you get eaten. And Jamie Riedel's talk on getting observability out of your monitoring system. So if you wanted to get more in depth about how to get better visibility to your applications, those would be 2 good talks I recommend. So with DevOps, team structure is important. And has anybody ever heard of Conway's Law before? That's a real thing where the systems that your teams develop are a reflection of what the organizational structure is. And so teams need to be given the responsibility and autonomy over their work. We want to design our teams in such a way to minimize dependencies so they're not waiting on each other and have to have all this communication and meetings. Think about your business and the way you structure your teams as products, not projects. So anybody hiring, this aligns with what millennials say they want out of a job, is to have autonomy and control over their work. And so I think there's a lot of synergy where you can be an attractive employer by having autonomous teams. Automated health checks are also super important for being proactive and making sure your system's in a good state. We want to check things like CPU, memory, hard drive. If you have prod go down because you're out of hard drive space, that's just embarrassing. We also want to be able to check the health checks of our dependencies and other systems. So we should be able to call an API to make sure everything we depend on is healthy. Also, to be able to check for non-activity. When you should be getting volume and there's nothing coming in, you should be getting an alert for that as well. So health checks are kind of like unit tests that run in production, but they don't change any state, and so they just notify you when something's weird. So this is a tweet from one of my former clients that made me smile. This is a good sign of progress. Yep. We want to make our applications notify us when they need attention. So this includes any health check failures, of course, but also like if the queue depth or if they're getting behind in processing, if too much data is coming in and they can't keep up, or maybe we're outside of our cost per hour parameters. So if all of a sudden your costs are 10 times what they should be, you should be getting a notification to go check that out and see what's happening. So first thing we want to do is make sure we have our deployment pipeline all scripted out. Check in your code, run all the tests. When the tests pass, you publish a binary. The binary is available. You kick off performance tests maybe or some other quality gate. And then when that's verified, it's automatically deployed to production. And then your infrastructure, this is also what we want to script out. You might hear the term infrastructure as code. So we'll define the deployment stack, and this is also going to be where you have your server instances, your queues, your security keys, firewall rules, load balancers, anything your application needs in its runtime environment. Script it out so you can invoke an API and then create those stacks. Feature toggles are also a strategy that helps you decouple the deployment timing from releasing the features. And this keeps everybody developing code off of the main line, and so you don't end up with merge ambushes, where if you've got everybody's code on a separate branch, and then at the end of some PSI commitment or some Scrum sprint, everybody merges their code at the same time, and then your code doesn't merge cleanly because of everybody has changed the code. You're going to spend days trying to merge code or perhaps rewrite it. We call that a merge ambush. So if you have a code freeze, you're doing something wrong. That's a bad sign. So feature toggles allow you to keep your code off so the customer doesn't see it, but merged. So programmers see the code and they can work around something. And if two people are changing the same code at the same time, maybe they should just be pairing on that. Maybe there's multiple features where that have the same place of code that needs changed. So bonus points if you let your customers toggle these. Everybody used Google Labs before, where you can turn on experimental features? Maybe just a subset, but that would also be something that you could not expose these new features or these features that are maybe untested to the entire market, but they can be available in your code base. So some consequences of DevOps is that you get better logging. When the person who writes the log is the one that gets to read the log when something goes wrong, there's an incentive there to have that log contain all the information that's necessary to figure out what the problem is. And especially with ephemeral servers, if you don't have logs, there's not a good chance you're going to figure out what's happening. Also, if you're able to change the logging level at runtime, that can also be a benefit in case you're overwhelming your log server with too much. So here's another tweet that made me happy, or definitely resonated with me anyways, in regards to logging. All right, so also with DevOps, we become responsible for economic tuning, not just performance tuning. And this is where the developers should be seeing the billing statements that come from the resources running on the cloud platform, so that if we have stuff that's underutilized or maybe something that can be tuned to be more cost effective, that feedback is coming in. So we're not essentially just wasting money. We're using the resources that, it's like turning off the lights when you leave a room. We want to make sure that we are utilizing resources efficiently. And that when the cost becomes a lot more evident, rather than servers you've already purchased, you've already upfronted the money for those, versus servers that you essentially rent. So also bonus points here if you're able to put your cost per hour on your team's dashboard. So these books are a great place to get started. If you haven't mastered continuous delivery yet, I consider it almost a prerequisite. You should be your deployment pipeline should be pretty solid, pretty reliable. And this book talks about a walking skeleton that helps you get all the pieces in place in order to deploy code effectively. And then the Lean Startup is another book that talks about how you make sure you're working on the right thing. How do you do market testing? How do you know if what you're delivering is going to be effective? This is what your customers want. So Jez Humble and Eric Ries got together and made another book called the DevOps Handbook. It seemed kind of like a natural progression here. And so if you want to get started with DevOps, this is a great place to read up and get some background information and know where to start. And then the Phoenix Project, I suggest the audio version for this book. It reads more like a novel. So it's like a story about a company and what happens as they try to go on this DevOps journey. So your investment will help you build a value stream for low risk, frequent releases. And from here, you can do A/B testing and test your market ideas. So this is the shift where with DevOps, instead of IT being a cost center, IT becomes a strategic advantage for your business. So the key to unlock game-changing benefits is focus on reducing complexity. Keep your pipeline simple. Make sure everybody understands how your stack works. And once we master the tools and technology and know when each one is appropriate for a situation, you're going to see a lot of benefit to what your superpowers are with your business. So I covered what is DevOps, what it isn't, how do you avoid DevOps disasters, and then identified some of the effective DevOps practices that I've seen. So go try DevOps for yourself. Make sure you keep it simple. Don't underestimate the investment you're going to have to make in training, reading books, watching screencasts, doing some spikes, experimenting with technology, and get help if you need it. So if what you're trying to do seems super hard or complex, or you can't find a solution because it seems like nobody's ever done this before, you probably need to step back a little bit and figure out, can you simplify the overall pipeline the overall process rather than try to zero in on the technology, because we kind of tend to do that as nerds. We want to solve the problem rather than step back and look at the big picture. And so here's the secret. Like, implementing all this DevOps stuff and test automation and health checks, that gives us as coders a chance to write a lot more code. And we shouldn't treat that code as a second-class citizen. That should also be considered production code. And this also helps us avoid doing boring manual stuff that's subject to being error-prone when done by humans. All right, so that's all my content. If anybody has any questions, comments, stories they want to share, find me, and I'd love to have a conversation. Thank you.